So let's use the knowledge we already created, whatever you learned so far, to understand why Venus is so hot. And I already suggested in the previous podcast that it is not just related to the fact that it's closer to the sun than Earth. Okay, so the temperatures are much warmer than the additional energy or more energy you receive because you're closer to the sun. Okay, so here from Earth we can see Venus pictured above the moon in this image. Just as the sun sets or rises, Venus is often called the morning or the evening star. Okay, so Mat Mons, Venus' largest volcano, as photographed by Magellan space probe. Venus has been observed by satellites, I think starting in the 1970s at least, and often it was claimed that we know more about Venus than we do Earth, but now of course that's not the case. But we have a lot of interest as to why we want to look at Venus. Here it's always dark here, hardly any light shines through the clouds. That tells you something about the climate of Venus, right? So Venus is the hottest planet in our solar system at 867 degrees Fahrenheit, 464 degrees Celsius. Its surface is much hotter than a standard kitchen oven. So you do cook things at 400, 500 degrees sometimes, but not very often. So why is it so hot, the surface? Venus is the second closest planet to the Sun and the planet nearest to Earth. It is covered in thick white clouds which reflect the sunlight. This makes Venus sparkle more brightly than any star that we can watch with naked eyes. The clouds also hide the planet's surface. Space probes use radars, right, to see through them. What is a radar? You can go and look them up. I don't have a podcast on radar, but you probably already heard about it. And okay, radio wave detection and range, we won't go into details, but basically when you have too many clouds you cannot see with naked eye through them, so you need some kind of a light or wave that can go through it. And as we said, sun's energy has all the wavelengths. It has gamma rays, X-rays, ultraviolet, visible, and it has infrared, radio waves, microwaves, and so on and so forth. So what does it mean for Venus then? If it has so many white clouds and can make it shine like this, that means it is reflecting a lot of the sun's energy right away, and yet it is so hot. Why? With the knowledge you got already about energy balance, you know that this must mean that whatever energy it is receiving through the clouds from the sun, it is sending out less and less, so it is keeping more and more of the energy inside. It's the balance that matters. Some energy is getting through the bright white clouds into the interior, and thermal energy is being produced as it is on Earth by heating everything. Could be gases, could be surface, whatever. And that thermal energy has to go out to keep the temperatures at some level. If you keep a lot of that energy trapped, then you can keep warming the temperature. It's that simple. Okay, so too hot for me. Why is Venus so hot? The atmosphere on Venus made mostly of a gas called carbon dioxide, which is on Earth too. It is known as a greenhouse gas. Greenhouse lets the light in and also block the heat inside from getting out. So we will learn about greenhouse effect in the next section, but we will introduce this greenhouse gas called carbon dioxide, which you may have already heard of for sure. I'm sure you have heard of. So it allows sun's energy to come in, but it does not let the thermal energy go out. That is how it blocks, acts like a blanket. There are other greenhouse gases that we will look at, and we'll see briefly why they trap the outgoing long wave energy and not the incoming short wave energy. Right? So this makes it warm inside. Carbon dioxide has the same effect on Venus. Light from the sun shines through the gas and heat is trapped by the atmosphere. This is what makes Venus so hot, which means Earth has got a better balance where it's receiving sun's energy and losing a lot of the thermal energy, so that temperatures are not at 464 degrees centigrade. Our average temperature at the surface is about 15 degrees centigrade. Right? So this is what we have to remember. So few craters. Venus has some craters but had many more in the past. Every few hundred million years they become smoothed over with volcanic lava. We'll learn about volcanoes a little bit later as well. It turns out they are also part of the climate story. Miss Frizzle here says the first unmanned spacecraft to land on Venus arrived in 1970. I just mentioned it before. It sent weak signals from the planet's surface that lasted for just 23 minutes. Lot of engineering, lot of technology is needed to build something that can go all the way to Venus and land there, and then it has to send messages back, and it will be designed for the warm temperatures, hot temperatures on Venus, and yet sometimes it doesn't land properly, as you saw with the Indian moon lander, and sometimes it lands and crashes like Indian rover did on Mars, and sometimes it lands and cannot survive for too long. So space business is very tough, but it's a very fun business. I didn't put Mars in the same sequence, so let me jump to Mars and then we'll close this here. Mars is red. Its red color comes from iron-rich rocks. The idea is that iron rusted when there was water on the planet, right? Oxygen, water has dissolved oxygen, rapidly rusts or oxidizes iron. So you have dry valleys. Castle Valley is one of the longest valleys on Mars. Scientists think it was formed by water rushing through this area billions of years ago. There is no water here now. There are volcanic giants. Pavonis Mons is one of the several giant volcanoes. The largest of the Mars's volcanoes is 3 times taller than Mount Everest. 3 times taller than Mount Everest, which is the tallest peak on Earth. Deep canyons exist. Mars has a giant system of canyons called valles marineris. These are some derived scientific terminologies. It's 4 times deeper than the Grand Canyon and would stretch right across the United States. So Grand Canyon is in the United States, stretching across Arizona and a couple of other states, and a fantastic place to visit, and it's massive. So this is much deeper, 4 times deeper than the Grand Canyon. Okay, so obviously humans have a lot of interest in going to Mars, maybe settling down on Mars. Discussions and plans and engineering challenges being addressed about putting people on Mars and living there for some time, because it'll take a long time to go and a long time to come back, and maybe you don't come back or you don't even land. So let's read a little bit about that. I think I'll stop after that. Yeah. So of all the planets in the solar system, Mars, the red planet, is most like Earth. If humans ever decide to visit another planet, they will almost certainly go to Mars first. For now, scientists use rovers, which is a robotic spacecraft with wheels, to drive across Mars and find out more about the landscape. So here someday we could be Martians. Could humans live on Mars? This is by Phoebe. Mars is a harsh place. During the day it never gets hotter than 68 degrees Fahrenheit or 20 degrees Celsius, and at night it can plunge to 193 degrees below zero, minus 25 degrees Celsius. That's much colder than Earth's south pole. However, there is carbon dioxide on Mars, which is what plants need to grow, astronauts could set up greenhouse there, a greenhouse which we'll look at in the next section. To grow food, plants give out oxygen. One day, humans might be able to use plants to turn Mars into a small version of Earth. There's a whole question of whether this is a good idea or not, but nonetheless, robot eye cameras and laser beams study Martian rocks. They are looking for signs of water and even life from past times. So as we said, it takes a lot of skill, technology, science and engineering to figure out how to go to Mars, how to land, how to move around on a rover, and how to explore land and rocks and so on. It's not just imaging, it's not just taking photographs. You're actually going to poke the stones and look at the chemicals and so on and so forth. Okay, so it's the size of a small car. Rocky road, 6 wheels move up and down. They can drive over rocky ground and through patches of sand so it doesn't turn over and fall apart. Nuclear engine, a nuclear reactor powers the rover. Spacecraft is controlled by radio from Earth. So we can sit here and play a video game on Mars, which is remarkable. But we have to be careful, because if we send nuclear engines and we start to create radiation pollution on Mars, then what happens? Miss Frizzle says Mars is a cold and completely dry red desert today, but scientists think seas and rivers once flowed over its surface. This is another detective job, to go and figure out if Mars ever had water on it. Why do we worry? Because we think water is an essential ingredient for life to evolve, but of course we don't know what other forms of life there may be. Plus, if there is water, that means Mars's climate, if there was water, Mars's climate was very different before, and we have to understand that to understand the future of Mars's climate and the future of our own climate as well. So let's stop here and come back and look at Earth a little bit more before we move to the next section. Okay, so please keep writing down your questions and find ways to send it to me. If there are a few comments on the channel, then maybe I'll open up email address to contact with me directly. Okay, see you in the next podcast on Earth.